Okay, so this is 3.2. This is synthetic division. This is a little bit shorter than the last couple of lectures, so hang in there. We only have a few more weeks. All right, so the division algorithm. So basically what you're going to do is it says that if you have two polynomials, all right, so you have two polynomials, and what you're going to do is you're going to take one of them will be equal to the other times another, that's a Q and a G, plus a remainder, okay? So basically you take two functions, you multiply them together, you're doing division. It's the opposite of multiplication. And yes, we do that with letters too, and I know y'all hate that. So to avoid errors, you're going to make sure you use 0 for coefficients if you're missing any exponent. So for example, in this problem here, you have an x cubed, an x squared, an x, and a 2. So it goes 3, 2, 1, nothing. So you're not missing any terms, so you don't have to worry about putting a 0, okay? Now to use synthetic division, you take this. So this is your x plus 2, and the way it's going to convert is this plus 2 is going to be, you're going to divide by a negative 2. So you're going to write your negative 2 down, and you're only going to write down the coefficients. You're not going to write down the variables. So the 5, negative 6, negative 28, and negative 2. So you write it down, draw a line a little bit under, and you bring down that first term. So you just bring this down. Now multiply. Negative 2 times 5 is negative 10. Now add these two together. Negative 6 plus negative 10 is negative 16. Now multiply by negative 2. So it's constant. Multiply, add, all the way till you get to the end. So negative 2 times negative 16 is 32. Negative 28 plus 32 is 4. Negative 2 times 4 is negative 8. And negative 2 plus negative 8 is negative 10. So now, this was your x cubed. Now this will be your x squared. So now your response is 5x squared minus 16x plus 4 plus negative 10 over x plus 2. Because this part right here is your remainder. Remainder. I guess it'd help if I could spell. Remainder. So this is the answer to dividing that function by x plus 2. Like we did here, because this is your x minus negative 2, which is why we used the negative 2. Now, if there's a special case, so for any polynomial f of x and any complex number k, there exists a unique polynomial q of x and number r such that the following holds. So we had our x minus k, which would be that x plus 2, the function we got, and then we had our remainder. So the remainder theorem says if a function is divided by x minus k, the remainder will be equal to f of k. So let's look at this first example. So we have 4, 2x. So do you see it skipped the 3? So what we're going to do is we're going to rewrite this. This would be negative x to the 4th plus 0x cubed plus 3x squared minus 4x minus 5. You want to make sure that you got that 4, 3, 2, 1, nothing. Make sure you do that. If you leave out the 0, it throws the whole thing off. And then you have to start over. All right, so they're saying to find f of negative 3. So we're going to divide by negative 3. We don't have to change the sign on this one. This one is telling you it is negative 3. So now we got negative 1, 0, 3, negative 4, and negative 5. So I'm going to do the same thing. Bring this down. Now go through and do your multiply and add, multiplying, add. Negative 3 times negative 1 is 3. 0 plus 3 is 3. Negative 3 times 3 is negative 9. 3 minus 9 is negative 6. Negative 3 times negative 6 is 18. Negative 4 plus 18 is 14. Negative 3 times 14 is negative 42, and negative 5 minus 42 is negative 47. So that means that f of negative 3 is equal to negative 47. And also remember, this was your x to the fourth, so this would be negative x cubed plus 3x squared minus 6x plus 14 plus negative 47 over, and that would be x plus 3. That's how it would be written. The potential zeros. So now a zero of a polynomial function is a number such that f of that number is equal to 0. Real number zeros are the x values of the x-intercepts of the graph. So a zero of a function is a root or solution of the equation. So f of x equals 0, which is what we've been doing. We've been setting things equal to 0 and solving them. So let's do some examples so you can kind of tie it all together. Determine whether the given number k is a 0. So they're telling me that k is 1. So we're going to take the 1 and we're going to divide it into. So we got 3, 2, 1, nothing. So that's a 1, a negative 4, a 9, and a negative 6. 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. 9 minus 3 is 6. 1 times 6 is 6, and negative 6 plus 6 is 0. So that means, yes, 1, 0 is a solution. So now try with a negative 1. And this is a different equation. So now we've got negative 1. And I see that I'm missing the 3, so it goes 4, 2. So that means there's a 1 and there's no 3. 1, negative 3, 1. So we don't have an x cubed, so I need that to be a placeholder. Negative 1 times 1, 0 minus 1. Negative 1 times negative 1 is positive. 1 plus 1 is 2. Negative 1 times 2 is negative 2. And negative 3 plus negative 2 is negative 5. Negative 1 times negative 5 is 5. And 5 plus 1 is 6. Since my remainder is not 0, negative 1 is not a solution. It is, however, a point on the graph. It is a point on the graph. It's just not a solution. So it doesn't cross the x-axis, but it is a point. All right, this next one is a little squirrely here. I'm going to do some of this on a separate paper because you have to do a lot of multiplying these imaginary numbers. So real quick, what I want to go over, and that might help understand, they're saying that 1 plus 2i, so I need to test that. So 1 plus 2i is the number I'm going to divide by. 4, 3, 2, 1, nothing, so my coefficients are good. 1, negative 2, 4, 2, negative 5. All right, so real quick, what I want to do is All right, so going through our same process as we did in all the others, we're going to do the same thing. So we have 1 plus 2i times 1. So that's 1 plus 2i. So negative 2 plus 1 is negative 1 plus 2i. So now this has to be multiplied by this so I can have a number for here. So I'm going to come down here and I've got 1 plus 2i and negative 1 plus 2i. So 1 times negative 1, 1 times 2i. 2i times negative 1, and 2i times 2i is 4i squared. These two cancel because they're the same thing. One's positive and one's negative. Negative 1 plus 4 times negative 1. That's negative 4. Negative 1 minus 4, so that's negative 5. So this is a negative 5. Now 4 minus 5 is negative 1. Now I multiply negative 1 times this. So now I've got negative 1 times 1, so that's negative 1. And negative 1 times 2i is negative 2i. Now 2 minus 1 is 1 minus 2i. Now I've got to multiply this times this. So now I've got 1 plus 2i times 1 minus 2i. 1 times 1 is 1. 1 times negative 2i. 2i times 1. 2i times negative 2i. These cancel. 1 minus 4 times negative 1 is 1 plus 4, so 5. So this is 5, and then negative 5 plus 5 is 0. So even though 1 plus 2i is a solution, since it's an imaginary number, it's not on the x-axis. It will not appear there, but it is a solution. So it is a solution, but not a real zero. And that is 3.2 in a nutshell. Go over something here. If you've got this I plus or 1 plus 2i, if I am to multiply this by 1 minus 2i or 1 plus 2i, negative, whatever you are to multiply it by, you're going to have to FOIL this out. So it would be 1 times 1 and then 1 times negative 2i, 2i times 1, and 2i times negative 2i, which would be negative 4i squared. This negative 2 and plus 2, these would cancel out, leaving me with 1. And then I squared is equal to negative 1. So this is negative 4 times negative 1. So negative 4 times negative 1 is a positive 4, and 1 plus 4 would be 5. So when you're multiplying these complex numbers that have i's in them, the I squared will always become a negative 1, and that will help you get rid of some i's. So I just wanted to bring that up because we're going to have to do this 2 times in this problem. And I don't want you to get lost while I'm doing that part in the middle of the problem itself.